Today we're going to start looking at section 3.6. Section 3.6 is going to have us name various types of triangles and their parts. So we've got quite a few vocabulary words here. Hopefully the majority of them you remember from maybe elementary school or even middle school. So we've got a scalene triangle. A scalene triangle is a triangle in which no two sides are congruent. So if I was to sketch a picture of a triangle, let's say I call it triangle ABC, if no two sides are congruent, well then every single side would have to be marked up differently. No two sides are congruent. So that would be a scalene triangle. If we're talking about an isosceles triangle is a triangle with at least two sides congruent. Okay, so a triangle in which at least two sides are congruent. There's a lot more vocabulary. I'll talk about that in a second, but if I have a picture, let's call this triangle DEF, we would have at least two sides marked the same. So notice that the two sides that I have in this picture that are marked congruent would be the segment DE and DF. Those would be then called the legs, because as you can see, legs are the congruent sides. So I would call this side a leg. I would call this side a leg. We call the base the side that is not congruent. So since segment EF is what's not marked up congruent, that would then be considered the base. So then we have base angles. Base angles are congruent angles that are located on the base. So notice that since the base is made up of the segment EF, we'll notice that angle E is on that base, and so is angle F. So those two are base angles. They are congruent. And then you've got that third angle at the top of this particular picture. That is angle D. We call that the vertex angle. So it's the non-base angles. So this angle right here is the vertex angle. So quite a bit of vocabulary when we're talking about isosceles triangles. But you have to have at least two sides congruent, which we call those congruent sides the legs. The non-congruent side is the base. We have two base angles that are located on the base and they're congruent. The third angle is called the vertex angle. Then we have equilateral triangles. These are going to be triangles in which all sides are congruent. So here's a triangle. I'm going to call it triangle GHI. If it's equilateral, then all of the sides are marked the same. So notice that because we actually have three sides, that means that we obviously have two sides marked the same. So all equilateral triangles will also be isosceles triangles. However, isosceles triangles might not be equilateral triangles. It just depends if the base is also marked congruent. Now let's talk about equiangular triangles. Equiangular, well, equal, just like equilateral. Angular, though, we're talking angles. So a triangle in which all angles are congruent. So if I sketch a picture, I'm going to call this triangle JKL. And I want to mark all the angles the same in order to consider this an equiangular triangle. And it says that all angles measure 60 degrees. The reason why each of these angles are 60 degrees is because three angles of a triangle will always add up to 180. So if all three of these angles are congruent, you're taking 180 and you're dividing it by 3, and that's where the 60 comes from. So three angles of a triangle add up to 180. Equiangular triangles, all of the angles are 60. All right, now we have an acute triangle. An acute triangle is a triangle in which all the angles are acute. And remember, acute means that that's going to be a measure between 0 and 90. So technically, the last picture that we just saw of equiangular, they're all 60 degrees. So they're all between 0 and 90. So technically, equiangular triangles are an acute triangle. All right, but it doesn't necessarily have to be that all the angles are equal. So let's say that I have an 80-degree angle, because obviously that's between 0 and 90, so that's acute. Let's say then that this is a 60-degree angle. Once again, that's between 0 and 90. So then this angle would have to be a 40-degree angle, because once again, all of the angles have to add up to 180. So if I add 80 and 40, that's going to give me 120. And then 120 plus 60 would give me 180. So all three angles do add up to 180, which is the definition of what angles of a triangle have to add up to. They're all between 0 and 90, so this makes this an acute triangle. So then we have an obtuse triangle. An obtuse triangle is a triangle in which one angle is obtuse. So remember, obtuse means that you have a measure between 90 and 180. But it can only be one of those angles. The reason being is because if three angles have to add up to 180, let's say that one of my angles is 120 degrees. Well, that means that I have two angles left over that would have to then add up to 60, because then 60 and 120 will give me the 180. So that's why I can't go having two obtuse angles, because then if you have something bigger than 90, well, anything bigger than 90, when you add it up, is going to add up with just two being bigger than 180. So let's say, then this is 30. So then that gives me 150. So then this would have to be 30 as well. So there is an obtuse triangle because one angle is between 90 and 180. Then we have right triangles. A right triangle is a triangle with one right angle. So just like an isosceles triangle, there are a bunch of vocabulary words that are associated with right triangles. But here's a picture of a right triangle because we have one right angle. I can't have more than one right angle in a triangle because 90 and 90, just two angles would then add up to 180, but I have to have three that add up to 180 in order for it to be a triangle. So here are some of the other vocab words. It says legs are the sides that are forming the right angle and are not necessarily congruent. So while legs of an isosceles triangle are congruent, they do not have to be congruent when we are talking about right triangle legs. So these two sides right here are forming the right angle, so those are the legs. Then we have the hypotenuse. The hypotenuse is always going to be the side that is directly across from the right angle. All right, so that covers all of the vocabulary that we need to know for this section. Let's start looking at some practice problems. So here I've given us a triangle. We want to name the following. We want to name what type of triangle it is, and then the vertex angle, the legs, the base, and the base angles. So hopefully we notice because we have a triangle with two sides congruent, we have an isosceles triangle. And so that's why we're identifying all these other vocab words. Remember, the vertex angle is the angle that is not on the base. So maybe we should identify the base. Remember, the base is going to be the side that is not a part of the congruency. So since DE is not marked up, that means that that segment is the base. That means the other two segments that are congruent are the legs. So DF and EF are those congruent legs. So then if the base is DE, the vertex is the angle that's directly across from it. So notice that angle F is the angle that's across from the base. So then the two angles that are on the base are the base angles. Well, that leaves us with angle E and angle D. All right, let's look at this triangle. We have to name the type of triangle, the legs, and the hypotenuse. So notice that right off the bat, I see that I have a right angle, so that makes it a right triangle. The legs are the two sides that are creating the right angle. So in this picture, it looks like that would be the side of MN and the side of NO. The hypotenuse is always the side across from the right angle. Well, across from the right angle is the segment MO. All right, let's take a look at this problem. It says the triangle SUN has angle S as 5x minus 2, angle U is 2x, and angle N is x plus 30. We're going to solve for x and then determine if we have an acute, an obtuse, or a right triangle. So we're trying to figure out angles of a triangle. They're giving us the expressions for angles of a triangle. So like I've been mentioning, 3 angles of a triangle will always add to 180. So 3 angles of a triangle add to 180 degrees. That's the thought process we want to be thinking about here. So since I'm giving us 3 expressions for the 3 angles of the triangle, I'm going to take 5x minus 2, I'm going to add 2x, and I'm going to add x plus 30. All 3 of those angles have to add up to 180. This is how we'll solve for x. So I start combining like terms. 5x, 2x, and x is going to give us 8x. Negative 2 plus 30 gives us a positive 28. This still equals 180. I'm going to subtract 28 over to the other side. That gives us 8x to equal 152. I'm going to divide by 8, and 152 divided by 8 gives us 19. So it said after solving for x, which we just got x to be 19, we're going to determine what type of triangle we have based off of the size of the angles. So that means I need to know, what is the measure of angle S? What's the measure of angle U? What's the measure of angle N? If I know each of those, that will help me determine if it's an acute triangle, an obtuse triangle, or a right triangle. So I'm going to substitute 19 in to each of these x's. All right, so 5 times 19 and then subtract 2, looks like that's going to give us a 93-degree angle. 2 times 19 is going to give us a 38-degree angle. 19 plus 30 gives us a 49-degree angle. So every single one of these is a different measure. Notice that none of them are 90 degrees, so it can't be a right triangle. One of them is 93 degrees, and since that is an obtuse angle, that means that we have an obtuse triangle. Okay, so then justify your answer with a written explanation. So because one angle measures between 90 to 180 degrees, we have an obtuse angle, giving us an obtuse triangle. All right. Okay, here's our next one. It says, if the perimeter of the triangle KID is 38, we want to know, is this triangle scalene, isosceles, or equilateral? So now we want to know the lengths of the sides, because remember, scalene, no sides are congruent. Isosceles, at least 2 sides are congruent. Equilateral means that all the sides are congruent. So if they're giving us perimeter, remember, perimeter means we're adding up all of the sides and setting it equal to the value. So I want to add up those 3 expressions and set it equal to 38. So we're going to have 2x plus 7 plus 5x minus 5 plus 3x minus 4, and that equals 38. That's how we'll set up perimeter. So combining like terms, 2x, 5x, and 3x is going to give us 10x. 7 minus 5 minus 4 gives us a negative 2. This still equals 38. I'm going to add 2 to both sides. That gives me 10x now to equal 40. So when I divide by 10, I find out that x is 4. But that's not my answer. I now want to plug 4 back in to each of my expressions. So the length of the segment ki is going to be 2 times 4 plus 7. Well, 2 times 4 is 8. 8 plus 7 gives us 15. Then I want to look at KD. That would be 5 times 4 minus 5. Well, 5 times 4 is 20. 20 minus 5 is going to give us 15. So notice that right now I see that both sides are congruent. So that means that it's not going to be scalene. It's going to be either isosceles or equilateral. It's going to be equilateral once I figure out what this third side is, if it's also 15. So we've got 3 times 4 minus 4. Well, 3 times 4 is 12. 12 minus 4 is only 8. So unfortunately, not all the sides are congruent, so it's not equilateral. So that means that based off of these sides, we have an isosceles triangle. And remember, that's because we have at least 2 sides congruent. So that's us naming various types of triangles and their parts.